Jennifer. I appreciate it. And I also want to thank everyone on the webinar who took time to join us today. I want to go over what we'll be covering today. It'll be a brief introduction to our user migration plan. We'll be sharing the resources on how to search, access, and discover and download PO.DAAC data in the cloud. And we're also going to share with you how you can collaborate and engage with PO.DAAC during this transition. At our first webinar last summer, PO.DAAC talked about why we're moving to the cloud. As missions develop higher resolution instruments, the need for larger storage volumes increases, and as well as the need for higher performing computing platforms. Missions like SWAT and Sentinel-6 Michael Freilich are going to be delivering data volumes in the petabyte range, and this is really pushing the limits of our existing archive and tool sets. For the last 40 years, PO.DAAC's been delivering data to their users from the JPL campus in Pasadena, California. However, in January 2021, PO.DAAC officially started migrating our data collections to AWS, to Amazon Web Services. This marks a new and exciting era for PO.DAAC as it fundamentally changes how we deliver data to our community. One thing we want to emphasize to our community is that PO.DAAC is going to continue to provide the same level of service and access to data in the cloud. Data search, access, discovery, and download will continue to be free for all users. PO.DAAC will also be launching new services that are co-located with the data in the cloud, and this will minimize the amount of data that users will need to download locally and allow them to select and access only the data that they're interested in. Of course, as with all transitions, there is an end to this journey, and by June 2022, we expect that all data and users will have migrated to our PO.DAAC cloud system. I want to emphasize here that tools like PO.DAAC Drive will be phased out as part of this transition, both as we transition our data and as we migrate our users. And we will not be maintaining support for PO.DAAC Drive after June 2022. So I want to cover some of the goals of our user migration. Our big goal is to minimize the impact and disruption that this migration may cause on our users. We recognize the importance of maintaining the needs of the users, maintaining the user needs and their workflows. And in that sense, we want to work with our community to ensure a clean transition. Communication, of course, is going to be key. PO.DAAC will notify all of our users as early as possible about data set and tool availability, whether it's through our mailing list, our web portal, our forum, or even a banner message in a terminal window. We want users to know when and how they can transition to using the cloud-enabled endpoints. We've also developed a centralized a web page that centralizes all of this information. It is the Cloud Data Migration page, and it's located on our PO.DAAC portal. Users can review the migration schedule, they can see what kind of tools and recipes are available, and they can see what phase their favorite data set is in. And we also recognize as part of this transition that users will need to modify their nominal workflows. PO.DAAC has developed recipes and tutorials and notebooks to help users discover, search, and access their favorite data sets. And we also plan to hold workshops and hackathons so users can gain some hands-on experience with our new cloud-based capabilities. And as you're working through these new tools, we want to hear from you about you and your use cases. We want to know what's working for you, what isn't working for you, and what we can do better. In addition to our help desk, PO.DAAC has set up a topic on our forum called PO.DAAC in the Cloud. Using the PO.DAAC forum, users can post questions, they can comment, they can engage with other PO.DAAC staff, and resolve any issues and challenges they may be having. Users can also reach out directly to our help desk by emailing podac@podac.jpl.nasa.gov. And at the bottom of each of these slides, you can also see the Cloud Dataset Migration page URL if you're interested. So I wanted to quickly share our migration schedule. I wanted to point out a few things. We started migrating our data in January of 2021. So this is the beginning of our timeline over here. And to date, we have 115 data sets that are publicly available in the PO.DAAC cloud. This data is being migrated in 4 phases, represented here by these purple bars. And at the end of each of the migration phase, at this point here, users will be able to access that data. And they'll be able to access it simultaneously for a period of time between PO.DAAC Drive and the PO.DAAC Cloud endpoints. At the end of each of these user migration phases, we will be shutting down access to data via PO.DAAC Drive. So I just want to reiterate that we've opened up the data access for phase 1 in July of 21. So that data is available right now. And we anticipate opening up the phase 2 data sets in November of 2021. Phase 3 will be available in January of 2022. And phase 4 will be accessible in March of 2022. This should give users enough time to develop and evaluate the new access mechanisms and to update their workflows and procedures. Of course, prior to each public release, we'll make sure that we broadcast a notification out to our user community indicating which data sets are available and how to get access to them in PO.DAAC Cloud. At the end of each of these user migration phases, these are the orange boxes here, PO.DAAC will be shutting off access to data via PO.DAAC Drive. Data sets for phase 1 will have their drive access shut down on January 31st, 2022. So right here, phase 2 and 3 data sets will have their drive access shut down on March 28th. And phase 4 data sets will have their drive access shut down on June 6, 2022. Of course, prior to shutting down access via PO.DAAC Drive, users will receive a notification about a week before indicating that the data will no longer be available from PO.DAAC Drive. Given this, we want to emphasize, or we want to encourage our users to begin their journey as early as possible so that they can gain experience accessing PO.DAAC data in the cloud. PO.DAAC will also be hosting a cloud webinar in November, and this will be a great opportunity for our users to gain some experience and get familiar with accessing PO.DAAC data in the cloud. Before I turn it over to Suresh to go over some of our new tools and recipes and applications, I just want to emphasize, kind of break this schedule down one more time. Again, the phase 1 data sets, they're currently available for all users. There's 115 of them in PO.DAAC Cloud. The next phase, phase 2, will be available for users in November of 2021. Phase 3 data sets will be available in January of 2022, and phase 4 data sets will be available in March 2022. You can see which data sets are in which phase by going to our cloud migration page on our portal. And as I mentioned in the previous slide, drive access will be shut off in phases as well. So expect to have that first phase 1 data sets, their drive access will be shut off on January 31st, 2022, phase 2 and 3 on March 28th, 2022, and finally on June 6th, 2022. So just to be clear, after June 6th, data will no longer be accessible via PO.DAAC Drive. It will only be accessible via the PO.DAAC Cloud endpoints. So now I'd like to turn it over to Suresh Vannan. Suresh is going to cover our tools and services that PO.DAAC will be offering to users to help them search, discover, access, and download data in the cloud. So Suresh, I will turn it over to you.
Thank you, John. My objective over the next 20-25 minutes is to walk you, the user, in terms of what it means to access PO.DAAC data from the cloud. Before we begin with introduction to all the different tools and services and the access mechanisms, the next couple of slides, we want to walk through what is cloud data access, walk through some terminologies, help you understand the architecture of storing and obtaining data from the PO.DAAC Cloud. So what you see right now on the left-hand side of this slide deck is the current mechanism through which you as the user are obtaining data from PO.DAAC archive. So we have the PO.DAAC archive on-premise, and using the Earthdata login, you get authenticated to our archive and you obtain data through a number of mechanisms, such as PO.DAAC Drive, OpenDAAP, threads, and so on. So this mechanism, as we transition to the cloud, will still exist. You as a user will still be able to access the data in the cloud archive using the Earthdata login, but the tools are going to look slightly different. Instead of the PO.DAAC Drive, we will have a mechanism called virtual browse. And features and tools such as OpenDAAC will still exist in the cloud. So you as a user will not have to change your mechanism in terms of how you search and download data products. The endpoints of where the data is stored will change, but in terms of downloading and processing the data within your own servers, those mechanisms will still exist. But the big advantage of moving to the cloud, as John mentioned, with the addition of some of these big missions, is this ability to transform and transfer your analysis directly next to the data. So this opens up a lot of opportunities for you as a user, and this is facilitated by providing you access keys to our cloud data storage. I will walk you through what it means to have these access keys, but the mechanism of obtaining data is now expanded to provide more opportunities for you as a user to exploit the data in the cloud. And again, a really important point to note over here is that you as a user will now have access to not only PO.DAAC data in the cloud, but now Earthdata in the cloud will be accessible. So now the opportunities and the scope of how you do the analysis has now expanded. And our goal is to allow these next generation of analysis and move your analysis next to the data. But that paradigm shift, anytime there is a change in technology, the terms and the names that we're calling for all these different things changes, it evolves. So what we wanted to do right now is to just give you a quick introduction to what it means with all these different terminologies. As we mentioned earlier, the PO.DAAC data, it will be in the Earthdata cloud. When we say Earthdata cloud, this is basically Amazon Web Services in the cloud. So beyond that, the data that's stored in the cloud is stored in what is called as S3 buckets. S3 buckets, in very simple terms, is very similar to your hard disk, but this hard disk is not residing on a server in a physical location at JPL or PO.DAAC. It's in the cloud, and it's basically called as S3 buckets. But what is stored in that is very similar to what you would have in a hard disk. So the PO.DAAC datasets, metadata are all contained within those S3 buckets. So when you hear this term, you could, in very simple terms, think of this hard disk in the cloud that's accessible through the web. The benefit of the cloud storage is that it's very scalable. The fact that the data resides in the cloud and is accessible from many different regions just provides a lot of opportunities. The AWS cloud is basically stored in many different regions across the globe. The PO.DAAC data and the Earthdata cloud data is stored in the US West 2 region. So all the data that you're accessing is basically in this particular region, and if your analysis is in that particular region, there is reduced latencies and faster processing speed. So these regions and zones are also important when you have large-scale compute that you have to perform on the data. So understanding what a region and zone is important in this particular context. I mentioned earlier that access to Earthdata is authenticated using Earthdata login. But anytime you access large quantities of data, it's just not practically possible to provide your login information and then sign into the system and obtain the data. So to simplify the process, we are providing what is called as AWS S3 access keys. In very simple terms, instead of using a password and a login, every time you access metadata or data within these buckets, you basically get a key. A key is basically just a string of random characters. I mean, I say random, but that is authenticated to your login, and you use those keys to access the data. So it allows you to script and generate your analysis scripts to utilize those keys to process the data rather than having to manage your passwords. So the scalable processing, it's also important to note that processing the data happens in the cloud as well, especially in a large-scale compute world. And the terminology that's used by AWS is called Elastic Compute Cloud, or in other words, EC2. So EC2 is basically your server or your processing system in the cloud. The big advantage of these systems is that you basically instantiate a processing system, process what you need, and then once the processing is done, you can shut it down and then move on. It's also scalable as well, especially when we talk about petabyte scale of processing and climate scale studies or integration of data sets across multiple domains. The advantages of using these sort of elastic compute changes. So with this terminology, we just want to provide a quick introduction. We understand that, in the scope of this webinar, in a course of a 60-minute webinar, it's very hard to remember these terminologies. So what we have done within Earthdata is provide a primer. So there is a glossary of terms and acronyms, and those are provided in that URL link that is shown on the slide. Now, with that introduction, now let's move on to the next series of discussion about the tools and the services that will be provided in the cloud. So we provided this table as a use case matrix, what we have right now and how are those tools and services going to be available in the future. I'm not going to walk you through every single one of these rows because those use cases will be described in subsequent slides, but you can use this as a cheat sheet of looking through your particular use case and see as to how that maps to in the future. We've also provided some interface parity, basically saying, is this sort of a one-to-one from what you have right now to what is there in the cloud, or is there a difference? And we've tried to explain this difference, and we're also talking about all the new capabilities that are being added to these features as well. So over the next series sets of slides and demonstrations, we'll walk through each one of these use cases and then provide you kind of like a Kickstarter process to get yourself thinking about moving to the cloud. I do want to emphasize, we've already emphasized this a few times, that the PO.DAAC drive is fully retiring in June 2022. And a feature that PO.DAAC drive provided, which is called the web dev mount, won't be available. We do understand that this is a feature that many of our users use, but that capability is not cloud native. But there are other options, there are other ways in which you could access the entire archive. And as I mentioned earlier, it's just not the PO.DAAC data alone now. Now you have access to a lot of Earth data. So now let's walk you through each one of these use cases right now. The very first use case is a browse and download. The complexity of the use cases increases as we walk through. And we understand that it is very hard to track these in the course of this webinar. So this webinar is recorded, and we will be providing access to the scripts and the videos on the PO.DAAC website as well. So you can just follow this along, and we will guide you in the future when you're ready to start using these capabilities in the future. So on this slide deck, what you see on the left-hand side is the current browse and download option through the PO.DAAC drive. So you log into PO.DAAC drive. Once you're logged in, you navigate through a series of directories until you find the data set that you need, and you click on the file and you download them. In the cloud mechanism, we have a feature called virtual browse. So this is the interface to the virtual browse. As I mentioned earlier, you have access to not only PO.DAAC datasets, but to all of the data across the DAAC archive. In this particular example, I've searched on a Sentinel-6 microfile dataset. This is a very recent dataset added to the PO.DAAC archive. There are more than one way in which you could access the data. There was a temporal subsetting option, and then a spatial option. So you can browse data in more than one mechanism. This particular difference in which you can browse the data right now in PO.DAAC drive doesn't exist. So this is a new capability that has been added with our move to the cloud. All of what you're seeing over here is driven by metadata. So in terms of temporal data, it's basically time. When was the data collected and observed? In terms of spatial, in the case of Sentinel-6 microfile, the data is stored in cycle and pass. So let's walk through this example where in my particular case, I've selected a cycle. I've selected cycle 22. And within that cycle, I can see all the different passes. And for each pass, there is a single file that's available. So say, for example, I'm not interested in the cycle in the past. I want to get my data by time. So I go into the year, and then the months at which the data was collected show up. I'm in August, and day 9, these are all the files that were collected on or observed on the particular day. So you as a user have more than one mechanism of browsing and downloading those data sets, and that option is available. I do want to remind you that the data endpoints are in the cloud, but for you as an end user, really it doesn't matter from where the data is being delivered. But there is an option of exploiting these many different ways in which we're storing the data. So our objective is to provide you more than one way of browsing and downloading the data sets. Now let's walk through the next use case. The next use case is a scripted access to the archive files. On the left-hand side is a forum post that we quite popular amongst the user community, where our users are utilizing tools such as curl and wget against the PO.DAAC drive and obtaining data. So this is a fairly popular way through which our users are obtaining data. With the move to the cloud, that option is still available. But instead of running your curl and wget against a directory structure, where sometimes the information and the metadata is not embedded, we're providing an option called the PO.DAAC data subscriber. So on the right-hand side is a URL link to a GitHub location where you could find the PO.DAAC data subscriber. On the next slide, I'm going to walk you through an example of executing a data subscriber. So let's just walk through this example. So in this particular case, I've logged into my terminal on my own laptop. I've installed a module that's required for this particular subscriber. This is a Python module called request. And then I'm installing the subscriber from the Git location. I'm not executing the script because I already have this installed, but those 2 lines are exactly what you needed. And then I've jumped into actually running the subscriber. So the subscriber is really driven as a parameter-driven script. So you choose the data that you want, the collection that you want, where you want to store the data, what sort of formats that you want, the spatial region at which you want to obtain your data. And then also a big feature of this data subscriber is to enable access to the archive on a periodic basis. A lot of users say, just give me the data that's been added to the archive over the last 60 minutes, over the last day, over the last month or so. This is particularly useful for our application users or operational users who utilize the data from the PO.DAAC archive. So you saw that the script ran. I've chosen the viewers data. Those 8 files were downloaded, and then they were copied over to my local disk. So I can CD into that location where those files were downloaded. And as you can see, those files were copied from the PO.DAAC cloud, from the cloud into my local device. So this interface really has, as I mentioned, parameters that you pass into it. So you pass in the data set that you want the data for. The formats, many data sets have more than one format of files in them. And in your particular case, in this particular case, I'm expecting netcdf or HDF5 data files. And I'm saying, I want only data that were added to the archive in the last 30 minutes, but give me the data for the entire globe. And then make sure that you log them into this log file. So the advantage of a script like this is that you can modify that script to your needs. There are multiple ways in which you can pass these parameters, and you can set this up as a cron job, and you can obtain the data. One important information that we receive from our users is this ability to use wildcard characters and scanning through the website, the PO.DAAC drive, and obtaining the data. So this data subscriber allows you to perform those operations and also enhance these script as well. I mean, the script is open source. It's available on Git. You can download that script and modify it to your particular needs. In fact, many of our users have modified them to their particular use case and have added additional features as well. Now let's move on to a little bit more, I wouldn't say complicated, but providing you access to the entire archive rather than this download model. I mean, the benefit of the cloud is to move your analysis to the cloud. Move your analysis, your scripts next to the data such that you can exploit the petabytes and the terabytes of data to your needs and actually do newer science with the data that's available. So as I mentioned earlier, the very first step to that process is to actually give you these credentials. Rather than passing in these username and password every time you access the data, now we have these credentials that can be obtained, and I use those credentials to access the data in the cloud. So the starting point for that are these two links. The first link will actually give you those credentials. Those credentials will look something like what I'm highlighting below. It's a secret access key that only you have. And then there's a README file that describes what these access keys mean. So this is a lot to perhaps digest if this is the first time you've heard these terms. So what we wanted to do is to give you a few examples, try and show you examples of how this could be made possible. How can you exploit these credentials to access the data in the entire archive? Let's walk through the very first example, a simple example. In this case, I have an Amazon EC2 instance. Okay, I'm just going to pause here for a second. If you've never looked at a AWS console, this is how it looks like. So I do want to remind people, I am not an expert in AWS, and I'm not a programmer by training. So I just wanted to encourage you to think about how you can move to the cloud. And our objective is to show you how simple this can be and really motivate you towards moving your analysis to the cloud. So what you're seeing over here is an AWS instance. I've logged into a console on the web, and it's showing me that I've got this system, my server in the cloud, right? It's basically a Unix system. And I'm logging into this Unix system. I'm connecting to it. So it provides me a terminal, very similar to how you would have a Linux terminal if it's running from your own shop. As I mentioned earlier, the first thing is to have these credentials. So I'm storing these credentials in this profile. And then accessing the archive is as simple as running an ls command. So what you saw earlier was a simple, ls command that you would run on a Unix terminal, a listing command. And now I'm listing not only just, the entire collections that are available in the cloud, but also individual files that are available. All I had to do was to open up a Linux system on AWS and then provide these credentials. And boom, I've got all the data right next to where I want to do my processing. So it's a very simple example just to show you as to how quickly you can access the data from the entire archive. Right? The power of being able to look through every single file in the archive. Now let's start to walk through a little bit more complex examples. I mean, I do say complex, but these are fairly simple examples. So I am now calling in an Amazon EC2 instance running in the cloud. This is running in the Amazon West 2 region. It's really important to remember that this access is only possible if you're in the same region. Now in this particular example, I've got a script that's running. I'm basically saying I need direct access to all of this data, and then I've run the code. That code looks very similar to what is shown on the left. It's basically saying, give me all the Muir data sets. And then I want to slice this data set and then basically do a plot, a very simple use case, nothing complex, but just want to show you the capability of accessing the entire archive within that. And with this line of code, I was able to process the data, do a quick plot of the Muir data sets, convert them into a Poincare projection, and then display them. This example was motivated by this Echo example, provided the Python notebook link. And the processing for all of this was less than $1, right? I mean, access to an entire year's worth of data, processing them, and the processing took just a matter of a few seconds. I didn't have to download any data sets, wait for that download, make sure that the download happened accurately, none of that. I went straight to processing the data. The processing took less than $1. I do want to remind people at this point that access to the data is free, but the data processing cost is the user responsibility. So that the data that you accessed, you're not paying for any of that, but whatever you're processing, that cost is the responsibility of you, the user. I understand this is perhaps the biggest bottleneck for somebody who's moving to the cloud, understanding how these costs work. So we have provided a lot of resources and help, and our partners within NASA and within PO.DAAC itself are doing a lot of work to educate and train users about this. So in the next particular use case, we've seen a lot of Python examples. A lot of our users love R. R is a fantastic software for statistical processing. And in this particular example, I'm running an R script. I'm basically logging into my Amazon system in the terminal, and I'm basically running an R script that I've set up. A very simple example, as you saw that the R script basically just took a few seconds for it to run. I just had a one line to connect to my Amazon Linux system, and then I executed this R script that's shown on the left. And keep in mind, I'm not an R expert, but the access to the data is made possible by these few lines of code at the top. Once I've got my AWS credentials, those access keys, the entire archive is available to you. In this particular use case, what I did was simply access the data, and then I processed the data to do a display, right? I mean, as I said, this is a very, very simple use case, but the opportunities and the scope is a lot now that you have access to the entire archive. I'm just going to walk through the next series of slides where we do talk about the existing tools and services. The next series of tools that are useful for us is OpenDAAC. OpenDAAC will exist in the cloud. There are a few constraints. There is no file listing at this point, and it is pretty hard right now to find the OpenDAAC links. We are working on fixing some of these. I do not have a timeline to say exactly when those will be fixed, but our objective is by the time we move purely into the cloud by June 2022, a lot of these constraints will not exist. I just wanted to let you know that these constraints exist right now if you are using OpenDAAC, where the data is actually in the cloud. The next use case is transformation of data. Transformation of data is possible through what we call as a Harmony API. Harmony API is a common web service API to access transform data across all of NASA's data centers. So this is just not a PO.DAAC tool. It's a tool that allows you to subset and transform data that's at PO.DAAC, that's at another DAAC. So basically oceanography data, cryosphere data, terrestrial data, if you want to mix them together to do earth science, the Harmony is a good tool to exploit and utilize. I'm just going to walk through a very quick example of how you can utilize Harmony within the Earthdata search client. The Earthdata search client is an interface for searching and discovering Earth data. In this particular case, I've discovered some Echo model output data. I'm interested in these 4 data products. I've selected them. I've said download these 4 data granules. But rather than just download, I have this opportunity to transform these data sets into other format. Transform them into a structure that allows for faster processing. So ZAR is a format that is basically cloud optimized. If you're not familiar with ZAR, the important point to note here is that it's cloud optimized and it allows for faster analysis of your data sets. So within our data search client itself, I've basically said process this data. You don't have to learn the API, use our data search client. It processes data and actually gives you those endpoints and puts those endpoints in an S3 bucket in this hard disk in the cloud. And now you have access to the data. So if you are interested in actually running your own script, here's a quick example. This sort of 5-6 lines of code exploiting a Harmony module. I'm showing an example of running this Harmony module and basically subsetting the data. So it takes a few seconds for it to run. It says that the job is being processed. Behind the scenes is basically looking through all the files that are part of this subsetting process. It's collecting all these subsetted data and then compiles them and then generates a process and downloads them to your local disk. So in this particular case, I'm running this script on my own laptop. But the benefit is that you're only downloading the portions of data that's actually needed for your analysis. You're not processing the data for the entire globe. There's only 4 granules that you've chosen, and the processing is happening somewhere in the cloud, and you're receiving only the processed data. So the processing complete, you saw that in real time. I did not speed up the script. It just took however long it showed. But it was a smaller processing logic. I just wanted to let you know it was not a pretty big analysis. But allowing you as the end user to get access to the data for the particular reason that you want is important as well. So this is an example of that Python script. It was borrowed from this example that you could see on the PO.DAAC. So the real idea is to give you some Kickstarter tools. I don't want to finish up this to say there are other tools and services that PO.DAAC provides. Threads, High Tide, Soto, and LAS. The main point I want to make over here with these tools is that we on PO.DAAC and amongst Earthdata and SDS, we're looking to improve these tools to make sure that we have a better user interface. The stability and the performance of these tools are up to a point where you can work on huge quantities of data. And also we're looking at better capabilities as well. We will provide you updates all along the way to help you, the user, to transition to the cloud and help you move your analysis to the cloud. As we mentioned earlier, the existing mechanisms of download and processing on your own device will still exist. But the power of utilizing the data in the cloud, we do want to start motivating and providing examples so you can make the transition as easily as possible. Now I want to transition my talk to my colleague, Sandra, who will let you know how can you get help from PO.DAAC beyond this webinar.
Thank you, Suraj. Hello, everyone. My name is Sandra Chosic. I'm PO.DAAC system engineer, and I will be transitioning to the last section of our presentation, which focuses on how to engage and collaborate with PO.DAAC during the PO.DAAC data migration to Earthdata Cloud, as well as where to find all these resources that Suresh already went over and demo you some of the tools and all the other resources to help guide data users in discovering, accessing, and utilizing cloud data. So I really wanted to start with our webinar theme. I really like the surfing ocean data in the cloud theme and the essential questions like the where, what, who, and how. We all understand that transitioning the processes and adopting new paradigm brings new opportunities, but also introduces challenges. Some old processes and tools may no longer be available or suitable, and there will be new tools and services, as well as a need to transition to those new processes and tools. So it is expected that we get questions like, where do you go to find information about cloud data access and resources? What does the new cloud paradigm look like? Who to contact if you have questions or need help transitioning your processes in the cloud? How much will it cost me to use cloud or download data? So where do you find information and answers to your questions? One of the options is to go to the PO.DAAC web portal and navigate to our new section called Cloud Data. There is a clear navigation item in the main navigation menu on the web portal, or just scan this QR code that we provided for easy access to this section of the site. The PO.DAAC Cloud Data page is the centralized location for all information about cloud data access and resources. It provides information about the new paradigm, pathways, examples to interact and access data and services from and within the NASA Earthdata Cloud. It offers access to resources to help guide data users in discovering, accessing, and utilizing cloud data. It also provides a connection to access data via tools and services, frequently asked questions, migration, detailed information, and more. I would also like to mention that this Cloud Data page will be evolving and continuously updated with new content and data. So we would like to recommend to check back regularly. So let's say you are interested in migrating to the cloud and you ask question, how do I do it? It really comes down to how and where do you start? Where do you find resources to support you in navigating the cloud migration? We have added a migration section to these cloud data pages to better prepare our users for moving to the cloud. You can find tutorials, data recipes, and many other resources on how to search, access, discover, and download product data in the cloud. There are so many examples here listed, like tutorials on how to find collections and granules, demos on data subscriber and data download, access to virtual browse interface, links to product cloud or data search portal. There is also access to Earthdata Cloud Primer documents that Suresh mentioned. This primer provides step-by-step tutorials on how to get started in the Amazon Web Services Cloud. And the tutorials are listed in the recommended reading order. So those are just some examples of the resources to start with in preparing for moving to the cloud. There are also the migration-specific FAQs that we've been compiling with answers to some of the common questions. And there is a new PO.DAAC forum called PO.DAAC in the Cloud, where you can post a question, you can collaborate with others on the specific topic, and see what others had to say or share. Like, we really want to see the sharing the best practices, data recipes. We also want to hear about the issues as well as the solutions of the same. Cloud Data About section describes access to PO.DAAC datasets in the cloud. You can learn about the new paradigm, get familiar with the cloud ecosystem, and find pathway examples to interact and access data and services from and within the NASA Data Cloud. It explains how in the new paradigm, the data storage and DAAC provided tools and services built on top of the data are co-located in the Earthdata Cloud. And as Suresh explained, all of that is really hosted in the Amazon Web Services Cloud. Here you can find also information on the services and systems like Earthdata Harmony, Earthdata Common Metadata Repository, and Earthdata Search. So regardless of the access pathway, services and systems like Earthdata Harmony, CMR, Earthdata Search can be really powerful resources in supporting data search discovery, transformation, and access for data use from and or within the cloud. The migration section offers information on the transition timeline and data sets, what to expect, in addition to tutorials and migration FAQs that I mentioned earlier. So in regards to the transition timeline, as John talked a little bit in more details, the PO.DAAC data will be migrated to the cloud in a set of 4 phases. On this page, you will find information on those data sets and the migration dates by phases. Users can also find information on what to expect while PO.DAAC is going through process of migrating its data archive to the Earthdata Cloud. And during this transition, some data will continue to be available from the local archive, while some data will also be available from and within the Earthdata Cloud. So during that time, there may be some duplicate collections available. And but then also there are ways to identify cloud-enabled data sets from the dataset search and dataset landing pages. Under tutorials, you will find a list of resources and how to search, access, discover, and download data. I already mentioned earlier direct links to all of these tutorials and examples and demos, and as well as the migration-specific FAQs. So how do you know when a data set will be migrated to the cloud? The dataset migration dates have been set for each phase, and they were listed in the tables, and those dates indicates when access to the collections in the cloud archive will no longer be available. If you're having trouble finding the collections in the table, the transition date is also listed on each collection landing page. It is important to remember that while the endpoints to the data are changing from local archive to cloud endpoints, download capabilities remain unaffected for the data users. So users will always be able to download data from PO.DAAC. There are several ways to see the PO.DAAC cloud collections. For public collections, you can use Earthdata search and the PO.DAAC web portal filter options. On the PO.DAAC web portal dataset listings, we added additional filter. And so you can select Earthdata Cloud enabled filter on the left-hand side to see a list of all the Earthdata Cloud enabled PO.DAAC collections. For PO.DAAC Cloud collections, on Earthdata search, so you can select available from AWS Cloud feature, checkbox on the left-hand side in the filtering options, or you can also search using the keyword PO.Cloud. PO.Cloud is a provider name for the PO.DAAC, indicating the PO.DAAC Cloud-enabled datasets. We also have PO.DAAC Cloud. For PO.DAAC Cloud collection, we also have built the PO.DAAC Cloud search portal, and we have the links provided in the resources page as well. So in the PO.DAAC web portal, the cloud-hosted datasets are clearly labeled as cloud-enabled in an orange rectangle. So this will let you know at a glance which datasets are cloud-enabled from the dataset search and dataset landing pages. You may ask, how do I know if a dataset is in the cloud or not? So in the PO.DAAC web portal, dataset search and discovery, that would be if you go to find data options from the main navigation, you may notice that there will be some duplicate collections available. For example, if you search for a specific datasets, you may see two collections returned in the search results. That is because one of these is our local archive hosted collection, while the other is the cloud hosted collection. In the future, after the date indicated for collection to be available via cloud only the cloud version will be available and you will not see the duplicates. So for now, you can rely that in the web portal, as I mentioned earlier, the cloud-hosted datasets are clearly marked with the cloud-enabled orange rectangle. This will be easy to spot and determine which datasets are cloud-enabled when you do the search on the web portal. You can also notice the difference on the corresponding dataset UI landing pages. So if you go under the Data Access tab, you will see that the tools and services are changing as the endpoints to the data changes from local archive to cloud endpoints. This is similarly you will notice under the documentation, where you will see a different set of data access resources like tutorials, data recipes, and everything that would be more in line with the data set and where that data set resides at. The resources section provides information updates, data recipes, and other materials that help support the user in discovering, accessing, and using datasets from and within the Earthdata Cloud. This is the cloud data filtered resources, and it is the place to find direct links to our PO.DAAC GitHub repositories. You can find specific data recipes, Jupyter notebooks, tutorials. You can find also our past webinars. data in action, what we call ocean stories, documentation, and more. It's for your convenience, there is a filtering by category, type, and discipline that helps you navigate and drill down when searching the resources on this resource page. So this is also the place where you will be able to find the link to our webinar that is recorded today. The Cloud Data FAQ page is fairly self-explanatory. Those are answers to frequently asked questions related to transition and migration to cloud. And these questions are often linked to topics in the PO.DAAC in the cloud forum, where you can collaborate with others on the specific topics, see what others had to say or share, learn about the best practices, data recipes. And if your question is not here, feel free to submit it to us via forum or by emailing directly to PO.DAAC at PO.DAAC, JPL-NASA Gov email. There are so many examples of FAQ questions, and this is the section also that will grow. And as we move further in this process. But some of those that you can find right now is, how can I get started using cloud data? How much will it cost me to download data from PO.DAAC? What cloud region availability zone, etc., is PO.DAAC using, and other things. So as Suresh mentioned, there is absolutely no charge to download the data from PO.DAAC. But if you'd like to do your analysis next to the data in the Amazon Web Services cloud, you can see the questions for cost associated with that. There are documentation available, and one of the resources is the Earthdata Cloud Primer, which contains a section on estimating and understanding the cloud cost. With that, I would like to wrap up this presentation with information on ways to stay connected. So if you need help, please reach out to us. Find resources to support you in navigating the cloud migration. Here are all the links. We provided the QR codes. One goes directly to our PO.DAAC Cloud Data pages. The other one goes directly to PO.DAAC in the cloud forum. Follow the links provided and find the resources to support you in navigating the cloud. Reach out to us if you have questions. As mentioned, you can submit your questions via forum. We prefer that way of communicating because then it becomes available for other users to see. Or you can directly send an email to PO.DAAC and PO.DAAC JPL-NASA Gov. All of those questions get to our help desk. They get processed, and based on the information, we either create FAQ or provide some information in the forum. For up-to-date information and latest announcements, we would like to encourage you to subscribe to the PO.DAAC mailing list. And here's the link to the web portal mailing list page where you can subscribe to. So PO.DAAC would like to use this webinar to get an understanding of end user use cases and assist its user community in adapting to this changing landscape of access to data. So we really want to hear from you. We would like to learn about your use cases, needs, best practices, as well as our challenges. And with that, I would like to thank you and also mention there are Earthdata, NASA Earthdata social media outlets, and you can use #PO.DAAC, and those are the outlets that we also share some highlights and important news from the PO.DAAC. With that, thank you so much.